Hi and welcome to everybody. In this short video I will show you how to quickly solve linear inequalities. Now I will show you what linear inequalities are. We mean that x appears only at first power. Here it's first power, here first power, here first power. We found x only with constants and parameters. This is a parameter, this is a constant, another parameter. If we found x as argument, a variable of a nonlinear function like sinus, or we found another power, second power, third power, we do not have any linear inequality. Look at now at the steps we have to follow to solve this inequalities. We have to group all x terms by one side. We have to group all constants together by the other side. We have to sum x and constants and divide by x coefficient. Now we obtain the solution and we graph the solution. Two things we have to remember. One, if we change side of any term, we have to remember to change its sign. Changing side, changing sign. This happens because if I want to change the side of this minus 4 from here to here, I have to change its sign. Minus 4 becomes 4 because I add the same quantity to both sides of the inequalities. If I add plus 4 or any quantities, but it had to be the same, the inequalities does not change. So we obtain 3 minus 4 plus 4 greater than 0 plus 4. You see, I have added plus 4 to both sides, so the inequality has not changed. But minus 4 plus 4 is 0, 4 plus 0 is 4. We obtain 3 times x greater than 4. Or, directly, without thinking all this, we can remember changing side, changing sign. Another thing to remember is this one. If I multiply an inequality with by any negative number, if I multiply one inequality by any negative numbers, it is minus 1, the inequality sign flips. Example, 8 greater than 5. This is a correct inequality. 8 is real greater than 5. If I multiply by 2, I obtain 16 greater than 10. This is a correct inequality. But if I multiply by minus 2, I have to remember to change, to flip the inequality sign, because minus 16 is less than minus 10. Again, also here, minus 8 is less than minus 5. If I do multiply by 2, I obtain the same inequality sign. I do not have to flip because I multiply by 2, which is a positive number. If I do multiply the same inequalities, minus 8 less than minus 5, by a negative number, in this case minus 2, I have to remember the sign of the inequality will flip, because 16 is greater than 10. Now we look at a very simple example. 3 times x greater than 4. We have to divide by the coefficient of the x, 3. So I obtain x greater than 4 on 3. Now I have to graph the solution. X equal 4 on 3 is the point at which this inequality annihilate. If I choose an x less than 4 on 3, I obtain a negative number. For example, if I choose 1. 3 times 1 is 3, and it's not greater than 4. If I look at 3x minus 4, I obtain that here it's less than 0. So this inequality is satisfied for all x greater than 4 on 3. Now look at another generical inequality. 5x minus 8 greater than 2 minus 3 times x. I group all the x there by one side. 5x, I leave it as it is. Minus 3x, I change the sign because I changed the side. I have minus 8 greater than 2. I change the minus 8 side and I obtain 8. I obtain 3x plus 5x plus 3x greater than 2 plus 8. So I obtain 8 times x greater than 2 plus 8. I mean 8 times x greater than 10. I divide by the coefficient of x 8 and I obtain x greater than 10 on 8. You see, this is the solution. This inequality is satisfied if and only if x is greater than 10 on 8. Now, let's look at another linear inequality. Again, minus 3x minus 5 greater than 8 plus x. We have to group all the x there by one side, so I move this x here, and I have to remember, I have to change the sign, and I have to move this minus 5 to the other side, obtain 8 plus 5. Remember, if I change the side of the number, I have to change its sign. Now we can add minus 3 minus x minus 4, 8 plus 5, 13. I obtain minus 4 greater than 13. I multiply by minus 1, so I obtain 4x less than minus 13. Remember, I multiply by negative number, so I have to flip the inequality sign. I divide by x, by 4, not by x, but by the coefficient of the x. I divide by 4, I obtain x less than minus 13 on 4. Solution is here, minus 13 on 4. If x is greater than minus 13 on 4, I verify the inequality. I have found one solution. Any number greater than minus 13 on 4 will not satisfy the equation. Any number less than minus 13 on 4 will satisfy the inequality. This one is very nice because minus 3x minus 5 greater equal 8 minus 3x. I have to change the place, minus 3x plus 3x, I change the side, greater than 8 plus 5. But minus 3x plus 3x is equal to 0. 8 plus 5 is 13. And it is impossible that 0, none, is greater or equal 13, which is a positive number, so by definition it's greater than 0. Let's see another situation. Minus 3x minus 5 greater equal 7 minus 3x minus 12. What I do obtain? Minus 3x plus 3x greater than 7 minus 12 plus 5. Change side. That means minus 3x plus 3x is 0, but 7 minus 12 plus 5 is equal to 0. So obtain 0 greater or equal 0. Only solution is x equal 0, equal to 0. In this situation, you can think that we have only one solution, x equal to 0. This is incorrect, because we eliminate the x. So this is a always verified situation. Always 0 is greater or equal to 0. So this is an identity. For every value of x I do put here, I always obtain a value 0 which satisfies the condition, because 0 is greater equal to 0. In particular, 0 is equal to 0. So we do not have only the solution x equal to 0, but this is an identity, so it is verified for every value of x.